This is part of our 3-2 part 2 with word problems, and we're going to go ahead and focus right now on defining our variables and setting up our systems of equations. The next part of this, you'll go back and you'll solve it. So this should be done, and we're checking it. So we have Tom thinking of two numbers. The first number is 2 times the first number, plus the second number is 47. All right, so 2 times the first number plus the second number, and it's 47. In addition, the first number plus 3 times the second number is 81. So these is words right here, that's equal to. Now defining the variables, I'm going to let x equal the first number. So x is going to be the first number, and y is going to equal the second number. You can use other variables, that's what I'm using. And so in the first equation it says 2 times the first number. So 2 times x plus the second number, so add on the y, is equal to 47. So there's my first equation. The next one states that the first number plus 3 times the second number. Okay, the first number plus 3 times the second number is 81. So there is my system of equations. Now, when I go to solve this, which we're not focusing on right now, you could solve it using the elimination method by multiplying this equation by -2, or this one by -3, or you could solve for one of the variables, x or y, and then substitute it in. So your choice on solving it. All right, in the next one, we have someone eating McDonald's. So this person ate 2 McDonald's hamburgers and drank 1 medium Coke, and it was 770 calories, so this is our total. Another person ate 3 hamburgers and drank 2 medium Cokes. So the burgers are the same, the drinks are the same. Jack apparently got his refills, and Jack had a total of 1,260 calories. So here's my variable. How many calories are in a McDonald's burger and how many calories are in a medium Coke? So to define my variables, I'm looking right here. How many calories are in a burger? How many calories are in a drink? So it's your choice. You can use X and Y. I'm going to use H, and H cannot stand for hamburgers. H has to stand for the amount or number of calories. So amount of calories, but it's in the hamburger. Amount of calories in burger. So again, H cannot be calories, H cannot be burger, which I spelled wrong. H has to be the amount of something, a quantity. So let me fix that. All right, then the Y value, which is going to be D for drink, is the amount or number of calories in a drink. And we were specific that it was a medium drink that way, and it was a medium Coke. What was it? Medium Coke, because that would have the same amount of calories for each person. All right, so there are my variables. And then you almost are looking at this like a receipt. She had 2 burgers and 1 drink. So it'd be 2 burgers times the calories in a burger. So 2 burgers times how many calories? So if each burger had 100 calories, that'd be 200 calories. Okay? And then we're going to add to that, she had 1 medium Coke. So there we go. And her total calorie count was 770. So the 2H is the quantity times the number of calories. So that's total calories in burgers, total calories in drink, and that gives me a total of 770 calories. And then we have Jack, he ate 3 hamburgers, so 3 times the number of calories per burger, and he had 2 medium drinks, so 2 drinks. And his calorie consumption was 1,260. So here is my system of equations. Okay? Again, this is total calories from hamburgers, total calories from drinks, total calories. With this problem, again, this is a great one for substitution. To make my life easier, I would solve for D because I don't have to divide anything out. Or you could use elimination method. And if I was using elimination method, I would multiply the top equation by -2 to cancel that out. So your choice in what method to solve. All right, so we've got Johnny who owns a restaurant, and he has decided to charge $1.50 for 2 eggs and 1 piece of toast, and 90 cents for 1 egg and 1 piece of toast. So this is a very similar question to what we just set up, but instead of talking about the number of calories, we're talking about the cost. And so here are my variables. Every time to define my variables, it's right here. How much is he charging? I know that he gets 2 eggs and 1 piece of toast as one meal, 1 egg and 1 piece of toast. I don't know how much he's charging, okay? So I know the quantity, I need to know how much he's charging for each egg and each piece of toast. So in this one, since we brought up eggs first, I'm going to let E equal the cost of each egg. And I'm going to let T stand for the cost of 1 piece of toast. So again, you can use X and Y. It helps my brain to use the E and T. Remember, E does not equal egg. E is not the quantity of eggs, it's the cost right here. How much is he charging? All right, so if you think about this like a receipt, it'd be the quantity 2 eggs times the cost, plus the quantity 1 piece of toast times the cost, and the total bill for this first meal was $1.50. All right, so there it is. The quantity times the cost. The quantity times the cost. That's total money spent on eggs, total money spent on toast, overall bill. And then we go to the next one. We have 1 egg and 1 piece of toast. So 1 egg plus 1 piece of toast is equal to 90 cents. But I am putting this in dollars, so it's in decimal form. And there is my system. I don't need the ones in front of the variables, but I wanted to show that to reiterate that was 1 piece of toast times the cost. All right, so again, this would be an easy one to solve with elimination or substitution. And when you get your final answer, make sure you consider you're in decimal form, so you should be using a dollar sign with your decimal. All right, let's look at number 4. We're actually going to do a little bit more with this one. Altogether, there were 568 tickets sold at the play. This is a total. Altogether, 568 tickets. So that's going to be one of my answers. An adult ticket cost $5. A child's ticket cost $2. And the total ticket sales were $2,345. So total tickets, ticket sales. These are my 2 answers. How do I build it? So I'm going to put my variables up here. I'm going to let A stand for something with adult ticket. So how do I know what my variable is? I know the cost. I don't know the quantity. Right here, calculate how many tickets of each were sold. So A is the amounts or number of adult tickets. And those were $5 each. So I'm just going to squeeze that information in there. And then what do I have here? C is going to be the amount. I know the cost. I don't know the quantity. Oh, all right. Amount of child tickets. Defining the variables and actually knowing what we're doing is much better than just trying to memorize patterns. So here's an implied equation. There's 568 tickets. 2 types of tickets were sold. So if I collect all the adult tickets and all the children's tickets, I should have 568 physical tickets. So it's the adult tickets plus children's tickets is 568. The quantity plus quantity is total quantity. This should be an easy equation, but it's one that a lot of us get stuck on. Okay? So this is total quantity, and then our other total had to do with money. And we know that each adult ticket was $5. So it would be the cost, $5 times the quantity. So if they sold 100 adult tickets, 5 times 100 is $500 in adult tickets. And then it's $2 for every child's ticket, and they want $2,345. So we know the cost. We need to know what quantity we have to sell to get there. And that is our system. So this is very much like this equation, right? Quantity times cost, total cost. Here I know the cost, I need the quantity. But same idea, total money on adult, total money on children, overall money. All right, now I want to take this one step further. Again, you would use substitution or elimination to solve this. And when you get to the end, you should get these answers. You should get that there's 403, and you need to label it with 2 labels. There's 403 adult tickets. So that's what I'm talking about, 2 labels here. 1, they were tickets, and 2, specifically for adults. Okay? And the other answer for the children's tickets is 165. So you're going to go back and you're going to do the algebra to make sure that these answers are right. So this is my final answer. I've labeled it adult tickets and children's tickets. So the description and what it is. And the reason I want to go over that is part B is different. I can't set up part B unless I know this answer. All right, the theater manager expects to sell the same number of tickets. Okay, so we are using the 403 and the 165. We're selling the same amount of tickets, but they want to increase the sales to 3,554 by increasing the price of the adult ticket. So that means the child's ticket is staying the same. So it says find the new price of the adult ticket. So I'm going to let C equal the cost of adult ticket. So we're taking our information, but they're basically saying we need to bring in more money. We're going to sell the same amount of tickets. So let's increase the adult ticket cost. So the adult ticket is no longer $5. We're trying to find what works. So if you take this and you think about it, instead of having $5 times a number, you'd have C dollars times the 403 adult tickets that you're going to sell. So selling the same number of tickets to the next play. And then you would add on the $2 times the 165 children's tickets. And we want a total of $3,554. So we're using the same children's ticket cost, the same amount of tickets, but we're replacing the $5 cost with a new cost. So this is going to increase. All you have to do now is multiply, subtract, and solve for C, and that will give you the new ticket price for the adults. All right. We are talking about blending coffees. So this is something that you would take something, a more expensive coffee and a less expensive coffee, and you blend them to get a better taste, but a cheaper price point. So the blend is made up of these Arabica beans that sell for $9 a pound, and these African Robustas that sell for $11.50 a pound. So we have a lower price and a higher price, and our goal is to get 100 pounds of the new coffee, and then they want to sell it for $10 per pound. Okay, and it talks about there's going to be no difference in revenue from selling the new blend versus the beans separately. So the costs are set. So we want to know, here's the question, how many pounds of the Arabica and Robusta beans are required? So when you go to define your variables, you shouldn't be guessing what your variables are. I know the cost, but the total money is going to depend on how many pounds we have to buy. So it's always going to ask you a question, and that's your variable. So I'm going to let A stand for the amount, or number of pounds of Arabica beans. So you could say the amount of Arabica beans, but it's measured in pounds. You could say the total Arabica beans measured in pounds, or the number of pounds of Arabica. And I'm going to put in here for information that it's $9 per pound. All right, and then I'm using R for the Robusta. So this is the amount, or the number of pounds of Robustas. And that was the higher price point of $11.50. So there's all my information. Now let's put a little bit more here. Together, I want to mix this up and get 100 pounds. All right, and it's going to sell for $10 per pound. So there's all my information. Now, you absolutely don't have to draw pictures, but for some people it helps. So if you can picture these containers, these big containers in a warehouse of coffee, and then we're going to put it into one big container here. In this container, I have A pounds, or X pounds, and that is going to cost $9 per pound. And this has a price point of $11.50, and I want R pounds. So picture the quantity here and here, and I dump all this in, I want 100 pounds here. And I want a price point of $10. So if that helps you organize, that's fine. You can do this with the solution mixtures and things like that. All right, so here I go. There's I don't want to say it's hidden, but this is a total of 100 pounds. So the pounds of here plus the pounds from here is 100. So the pounds of the Arabica beans plus the pounds of the Robustus beans should give me 100 total pounds. Quantity plus quantity is quantity. The other one has to do with the cost. So it's $9 for every pound. So it'd be $9 times A. So if you buy 10 pounds of this Arabica, it's $90. And then it's $11.50 times R. So again, if you buy 10 pounds, it's going to be $115. How much is it going to equal total? Well, they didn't give us a total dollar amount. They told us it was $10 per pound. So one of the mistakes, so look at your paper, one of the mistakes people write is the 10 here. So it's $9 per pound times the quantity. $11.50 times the quantity. It can't just be $10, no way. 1 pound of this is $11.50. It's $10 per pound. How many total pounds do we have? 100. So you're really using that 100 in 2 spots here. Total beans and to give us the total money. We had a problem like this in the 3-1 worksheet. We went over it in a recording or in class. So we have someone that has $6.75. That is the person's total, okay? Here's one idea. She has 8 more dimes than quarters. So here's one equation coming from the total money. Here's your other equation from this expression written out. And it says right here, how many quarters does she have? How many dimes? So your choice, I'm going to let Q stand for quarters, but Q can't equal quarters. Q has to equal the number of or the amount of quarters. So you will get points for defining your variables properly. That's a point on the test. You will get points for setting up the system correctly, points for work and points for answers. So all parts of this count. D is the number of or the amount of dimes. Now, here's some knowledge that we already know that we have to bring into it. Quarters are worth 25 cents, but I'm going to put it as 0.25 so it's in dollars, just like this was in dollars. And dimes are worth 10 cents, so 0.10. So that's implied knowledge that you have to bring. And that's going to help me because a lot of people want to say that Q plus D is 675. 675 is the value, right? Q plus D is the total coin. So if Gina took her piggy bank and opened it up and we counted how many coins she has 60 coins, then Q plus D equals 60. Nowhere does it tell us how many coins she has. So this 675 comes from the value of each quarter times the quantity. So it's 25 cents for every quarter. So if she has 10 quarters, that's $2.50 in quarters. And then it's 10 cents for every dime. And that gives us a total of $6.75. So it's the money from the quarters and the money from the dimes, total money. Not the quantity. It's the value times quantity. Value times quantity gives us the total value. All right, the other equation says she has 8 more dimes than quarters. One of the mistakes is people see 8 more dimes, so they want to say 8 plus D. If you really read it, 8 more dimes than quarters, she has more dimes, doesn't she? Okay. 8 more, you're right. So when you go to write this, the dimes is equal to the number of quarters plus 8. So you have to be very careful when you read it that you say, wait, what does she have more of? She has more dimes. So if I know how many quarters she has, I add 8. Now, another way you could write that is you could have done the dimes minus 8 equals Q. If you took her dimes and took away the 8, you would get the leftover quarters. There is your system. All right, so Kevin's going to invest $15,000. That's a total investment, so that's one of my answers. His goal is to obtain an overall annual rate of return of 9% or $13.50 annually. So guys, this annual rate is meaning in the end of the year, he wants to get 9% back as interest. And that 9% back as interest would actually be $1,350. So I have more information than I need. His advisor recommends to invest in corporate bonds. Okay, so these bonds pay 12% and the rest in government-backed treasury notes, which pay 4%. These interest rates are not what you're going to get today, but we're going to use them. Here it is. How much should be placed in each investment? Okay, how much should be placed in each investment in order for him to achieve his goal? So I'm going to let B stand for the amount money put into bonds. Maybe you use C, I'm not sure. So B equals the amount invested in bonds. And to help my brain, I'm going to write down that that's a 12% interest. And then I will let N stand for the treasury notes, and this is going to be the amount invested in treasury notes. And that is going to be 4%. All right, so there are my two variables. And if you think about going into a bank and investing $15,000, whether you're giving them a check or piles of money, if you put the two investments together, you should get a total of $15,000. So B plus N should equal $15,000. In the next equation, we want to talk about the percentages. So again, this was the total investment, and total investment gives me a total investment of $15,000. And the next one, we want to look at the interest, okay? So we're going to leave this $15,000 in an account. And a chunk of that money, 12% of this total, is going to come back as interest. And 4% of this total is going to come back as interest. And I'm using the word of. 12% of a quantity means I would take 12% times this total. But since I'm writing an equation, I'm not going to use 12%. I'm going to convert that to decimal of 0.12 times B. So 12% of the investment will come back as interest. So if this was $1,000 that we put in, 12% of 1,000 would give us $120 in interest. So you still have your $1,000 sitting in the account, plus they give you another $120 just because of that interest. And then we're going to add to that 4% of the total investment as interest off of treasury notes. And the biggest mistake I get is people write 0.4, and 0.4 would be 40%. We want it to be 0.04 times N, and that is the total interest. So this is the interest off the first account, interest off the second account, and it's going to be a total interest amount of $1,350. All right, so I really didn't need that 9%. That was extra information. However, if I take 9% of the original investment, I will get that same interest. So if I take 9% times $15,000, I will get the interest of $1,350. So this was extra information, and it's showing you that they're taking a higher yield with a higher interest rate and something lower and averaging it to get about 9%. And so if you look at this, 12% is closer to 9 than 4. So there's going to be more money invested in the higher amount. So why would someone make two investments and not put all the money here? Well, when you invest money in bonds and notes and CDs or savings accounts, they're held for different things, different amounts of time. So for these bonds to mature, it's going to take a lot longer, and so you have to let the money sit and it's tied up. Also, if something's riskier, like in the stock market, you might get a higher reward, but a bigger loss if you lose money. So things that are going to keep your money locked up for a long time, or things that are going to be risky, will give you a higher interest rate, and something safe would be a lower interest rate. And again, these interest rates are nothing that we would see today. All right, we have one more problem here, and this problem is very similar to number 7. So we need a total of 12 liters of solution, and we want that to be a 30% mix. All right, so 12 liters at 30% is what we want in our final container. They have two solutions that we have to mix to get there. We have one that's a 25% acid and one that's 40% acid. So this one is too weak and this one is too strong. All right, so the question here is how many liters of each should she mix? That question always leads us to our variables. So both of these are just a solution, so I don't have different names for them. So I'm just going to go ahead and let X equal the amount of 25% hydrochloric acid, and then I will let Y equal the amount of 40% hydrochloric acid. All right, so those are my two variables. Now, if it helps you to draw that little picture, here are my little cylindrical beakers right here. I'm going to have these two beakers to mix into one big beaker. In the big beaker, I want 12 liters, and I want it to be 30%. So 30% of this will be acid, and the rest of it will be whatever solution we have. In the first one, we have a 25%, and we have X liters at 25%, and here we have Y liters at 40%. So picture taking the amount of liters from here, dumping it, these liters, and dumping it, and if I add up the liters from the first batch and the liters from the second batch, I will get 12 total liters. And then I'm going to do my percentages. So 25% of this is acid. So if there's 10 liters here, then 25% of 10 would be 2.5 liters of acid, and then the rest of it would be whatever liquid is in here. So it would be 0.25, 25% of the total plus 0.4, and that is going to equal, and here's where this is different. So it's total plus total liquid equals total liquid. So go back up. Investment plus investment, total money. And then we had a percent of this as interest and a percent of the investment as interest, total interest. Well, here I have a percent of the liquid, total acid, percent of the liquid, total acid, and it's not equal to 0.30, it's equal to 30% of the total. So percent of the total gives us that overall percent of that total. So it's really important that you understand defining your variables and understanding what you're writing for your equations. It wouldn't make sense to say that this equals 0.3. A percent of a total cannot equal a percent. It's a percent of the total. So there are your setups. The next step, now that we know we have our setups correct, is to go back and solve these using substitution or elimination method and make sure you write and label your answers. For example, whatever you get for this X, you would label it as liters of 25%, liters of 40%. So whatever your answer is, you would say it's blank liters of 25% hydrochloric acid. So there's almost two labels. You're measuring it in liters, and it represents 25% hydrochloric acid. And then you'd have this answer, so many liters of 40% hydrochloric acid. In these word problems with cost, and amount of, and quantity, none of your answers should be negative. So that would be a red flag. Always double check and make sure you're careful with your decimals.